Hey there, and welcome to another installment of Lab Reports with me. So we're going to go over last week's lab report. So I hope that your brain is still functioning just a little bit before you get all into the Thanksgiving mode and thinking about turkey and stuffing or dressing, if you call it that. Cranberries, pies, stretchy waistband pants to make room for all those. So I hope that I have your attention for just a little bit longer. Okay, so 2 labs again this week, false memory and mental rotation. So false memory is one of my favorite labs and also one of my favorite biases can you have a favorite bias that the brain does? It's one of my favorite. The idea that we could create these false memories in our head is pretty impressive and terrifying. So in this lab, the computer spit out a bunch of words 1 second at a time, and then gave you a list of words to choose from, and you had to say whether that word was on the list or not. In this experiment, they had distractor words, whether they were normal distractor words or related distractor words. The idea is that the related distractor words will pop up as something that you believe was on the list. And I will say that no matter how many times I do this lab and I know what they're looking for, this past time, 100% of, I fell for it 100% of the time. It's concerning, but it's fine. We'll move on from it. Okay, question 1. In regard to false memory experiments, what are related distractors? So in a typical false memory experiment, a participant, just like this one, shown a whole bunch of words related to a similar topic. They all had a theme. I hope that you were able to pick up on that. Then you are made to pick the word that would be on the list. And the words that are on this list include words, the ones that you have to choose, include words that were on the original list, normal distractor words, and the related distractor word. And the related distractor word is not on the original list, but it falls in line with the theme. So in the false memory demo, are participants more likely to recall seeing normal distractors or related distractors? Obviously, as I just explained, falling for it 100% of the time, related distractors. How can one access the accuracy of someone's memory? You can't. There's no way to do it. The only way to have access to it to prove that it is objective and not subjective is to have objective evidence. So you have a photo and you ask your sibling, hey, do you remember when we went camping when we were 12 and 14? What was there? And they're like, yeah, blah, blah, blah. And they put out all this information. You can then compare it to the photo. Otherwise, you can't believe anything that they say, especially family. That's ridiculous. All right, so come up a list of 10 words you think that could create a false memory. Well, let's stick with the holiday theme. I could put out a list that says turkey, gravy, stuffing, 10. Is that what we need? 10? That's a lot. Turkey, gravy, stuffing, carrots, Brussels sprouts. What else do you have? Biscuits. People have biscuits. Sweet potatoes, pumpkin pie, pecan pie, and one more. What's another one? Tofurkey. Let's throw that in just for fun. And then in the related list, I could pick out cranberry sauce. Boom. Tricked you. I'm amazing at this. And obviously the theme would be. So imagine 2 of your friends are discussing a film that they watched together. They disagree on some of the details, but one friend is more confident about the memory of the film than the other friend. Who should you believe? So we all have this friend, right? The one that gives so many details when telling a story. So let's say that I am the friend and I'm talking about a movie I saw. Oh, I just saw this great holiday movie where this elf goes searching for his father And in the process, he ends up at this schoolyard and finds a flagpole, and one of the little kids triple dog dares him to stick his tongue to the pole. And I'm telling you this, it was such a great scene because the kid's in this brown jacket and a bright green scarf, and the tongue sticks, and there's snow falling and the kids are screaming. So I just gave so many details, right, to make you believe that this is actual. I went down to the color of the shirt, the kids screaming, making it seem like I know what the heck I'm talking about. But anyone that knows good holiday movies knows that I have confused Elf and A Christmas Story. So don't trust me. Don't trust me. A patient visits their doctor, remembers the doctor was wearing a stethoscope, but later finds out because of a hearing impairment, the doctor doesn't use the stethoscope. Why might the patient have made this mistake? So it's likely that the last time that the patient saw the doctor, they saw probably a lot of items that they would expect to see a doctor in. Probably the white coat, maybe some scrubs. They would see a bunch of tools around the office. They would smell that antiseptic smell. They probably had a pen, a clipboard, everything like that. But we make this assumption that when we see these things, when we see a doctor, that there's one other part that's going to be included in this, and that's the stethoscope. So looking in the context of it, that seemed to fit. So your mind, put it in there. Good job, mind. So what kind of implications do experiments on false memory have for evaluating the validity of eyewitness accounts? So we're already familiar with the idea that eyewitness accounts are going to be used in law enforcement and things like this. Has anybody seen My Cousin Vinny? Yeah. So if you've seen My Cousin Vinny, you could understand the issue with eyewitness account. I think there was the old woman that said that she saw the two Utes. It's a reference to the movie if you haven't seen it. But it turns out she didn't. She's blind, probably didn't see it. Another guy's eyewitness account involved the timing using how he makes grits, and every good Southerner knows that you can't make grits that quickly. So all these eyewitness accounts were false memories. Great. So, along with that, as we discussed earlier, the only way to truly have evidence of this is to have objective evidence. So whether it's a video capture, a photo capture, something like that, that's the only way that we could really prove these events happened. Okay, moving on. Okay, mental rotation. So this one's pretty interesting too, to see not just in terms of memory, audio or words, but how our brain actually processes things. So that's pretty neat. In this experiment, they gave you two diagrams. You had to say if they were the same or different, and they had to be rotated. So independent and dependent variables in this demonstration. Independent variable was the degree of rotation, and the dependent variable was the amount of response time that you, the participant, had. What are the predicted results in this experiment? For all items being equal, the same shape, condition, and such thing, the participant's reaction time is expected to increase with the increase in the rotation. So it should be a linear, if you were to diagram it, a linear process that happens, rise over run, reaction time, and rotation. In demonstrations like this, participants often report they mentally rotate the objects in their minds in order to make their same different judgments. So why did researchers decide to take reaction time measurements also? Let's go back to that false memory lab that I just discussed. What are we looking for to prove that something happened? Objective evidence. So that is why the researchers took the reaction time, because that's something objective. Some of the other components, the verbal reports, especially on the mental processes, are all subjective. So it's difficult for participants to accurately identify the processes that they use. So the researchers brought in mental rotation reaction time. Nailed it. All right, in this demonstration, why are participants required to repeat the trial if they make an incorrect judgment? So the goal of this is to estimate the time to make that mental rotation, and not if they made a correct or incorrect answer. So by removing that component of it and only looked at the response time, that's going to be more representative of what they're looking to study, which is, the reaction time to understand if there's a greater rotation, there's going to be a greater processing time. How did Shepard and Metzler's 1971 findings suggest that mental images are similar to real images? So the same idea, the larger the rotation angle between the two shapes, the longer it takes to identify them as being the same or different. So this just indicates that participants are mentally rotating the images, just like it would take time to physically rotate something. So while we're doing it in our head, similar to actually doing it with a physical object. Describe some cognitive tasks not already mentioned in the text, in which one might utilize mental imagery. Well, this could be a lot of things. It could be the idea of, packing. If you are going to pack your suitcase, how are you going to move things to get in there? If you are going to decorate a Christmas tree, rotating the tree, figuring out how everything fits, even if you are explaining to someone where to find something in your cupboard. Let's say you have a cupboard full of canned goods, mentally rotating where things are. Very similar cognitive processes. All right, using the global data, predict the reaction time for making a same response if someone was shown two identical shapes, but one of the shapes has been rotated 140 degrees on the y-axis. So this could be done in a number of ways. One could find the difference in reaction time between the same shape with a 100-degree rotation data point and the same shape with a 120-degree rotation point. Then one could add the difference to the average reaction time recorded for the same shape with a 120-degree rotation point. So this would give a good estimate for making the responses when the two identical shapes have been rotated to 140 degrees. Does that make sense? You can't tell me if it doesn't unless you want to email me, but right now you can't. Anyway, so those are the two labs for this week, and I hope that you enjoyed them, and on to the next week's ones.